Do you want to learn how to create a RAID 0 on Raspberry Pi? Do you want to learn how to create a RAID 1 array on a Raspberry Pi? Do you want to see how to do this with a Compute Module 4? Well, stay tuned, and I'm going to show you how to do all of this. Welcome to another edition of Tech Bytes with Ron Nutter, your home for all things relating to smart home technology. In this episode, we're going to talk about setting up a home RAID lab using a Compute Module 4. Now, this is part 2 in the series. Hi, I'm Ron Nutter, and we're going to be working on this together. This content is also available as an Amazon Flash briefing or podcast. Please go to techbyteswithronnutter.com for more information. For any items mentioned in this episode, there are affiliate links in the description. If you click on these links, I will get a small commission, but that won't affect the price you pay for the item. If you want to get notified when new content is uploaded, please click on subscribe and enable notifications. Well, in part 1 of this series, I showed you how to set up RAID 0 and RAID 1 on a Windows 10 system, which is an Intel NUC. Now, for those of you that are a little more curious or a little more adventurous, I'm going to show you how to do it on a Compute Module 4. So the items that we're going to be using in this particular video are the Compute Module 4. Now, this is the one without Wi-Fi on it, because that was the first one I could get my hands on. So I'm going to continue to move forward with that one. I've also got now one with Wi-Fi. So we'll be taking this one step at a time. We're also going to be using the Compute Module Raspberry 4 I/O board, because that's what's going to give us the ability to tie into Ethernet and a whole host of options. Something to keep in mind, if you notice down on the bottom part of the board, just to right of center, that's the USB ports. And we're going to have to do a different setup sequence for these, because by default, those are disabled. But it takes it takes going into one file and adding one line, and we can take care of that. This does require a 12-volt power supply. That obviously is going to be in the mix as well. And it has multiple tips, and you'll find the right one, because they come with a whole host of assortments. Now, I've also done a 3D printed base. This is something I'm actually going to modify, and I'll put up an STL file on Thingiverse, this carrier that I printed with the holder that I printed on my 3D printer for the Compute Module 4 I/O board. I want a little more support in the middle. So what I'm going to do is modify the design I found and add some more support in the middle, because that way I can take the Compute Module on and off the I/O board without flexing the I/O board. And it flexed a lot more than I was comfortable with. Well, let's go ahead and get the micro SD card inserted in my Intel NUC. And so it's already discovered that. So we'll flash from file, and let's go over here to the latest version of Raspbian when I got a hold of this, and we'll go through the process of getting it burned, and then we'll proceed on to some modifications we've got to make before we can boot up the Compute Module 4. Now that we've got the SD card created, I'll still say the word burned once in a while. It's old habit when you've been working with CDs and DVDs. So we'll go over here and create a text document that's SSH with no extension and hit enter. We're going to get the warning about file extension unusable. We'll click yes. That is the next part. What you'll also want to do is we're going to have to add what's called an overlay. This is going to allow the USB ports to come up. So we'll go down here to config.txt file, go all the way to the bottom, and then we'll put that line in so that it knows that it can bring up the USB ports and allow them to be usable. Now we'll move the card over to the Compute Module 4 on the I/O board. So we've got the micro SD card in the Raspberry Pi Compute Module 4, and we should have power coming up here. Okay, I've got the status lights on the board and seeing the network jack come up. Okay, now we've got that, so we should start seeing this come up. So it's resizing it. Okay, that's fine. And this is a good indication that it is reading the SD card, or we wouldn't have gotten that far. So it's going through, it's restarted the post process after resizing the card. And see, the fact that we're getting in with the keyboard, which I'm plugged directly into the Raspberry Pi, then we're set to go. So that says we've got the USB ports active. So that's even better. So now we get to start working with getting RAID 0 and RAID 1 in place. Before we get too fancy, we've got to make sure we get the latest updates applied. So we'll do sudo apt-get update, and this will make sure we've got the latest files in place, at least the latest directories of where they are. Okay, and when we get into this, I'm going to switch over to an SSH session, because this is coming up at a pretty high resolution, so I want to make the font a little bit easier to read. So sudo apt-get upgrade, and remember the -y, because that's going to automatically answer all the questions, doing the answering of the yes that you're going to need to worry about. Okay, now that we've got all the updates applied, let's go find out what our IP address is. We'll just type ifconfig, so it's 10.0.1.70. Okay, so we're good there. So I'm going to switch over to the Intel NUC, and we're going to bring up 10.0.1.170, and we'll make it up to something a little more readable. And yes, it's not in there, so we'll say yes. Okay, now this should be a lot more readable. So we've got it up and running. We're coming on an SSH. So now we need to install something called mdadm so that we've actually got the RAID commands available within Raspberry Pi. Now, just to be on the safe side, we're going to see if we actually see the USB controller and if there's anything plugged in. So that's what we're seeing right out of the gate. So that says we're seeing the hub. So we're seeing the 2 ports. Now I'm going to go over here and plug in one of the drives. It's got powered up. So now if we repeat the command, okay, now it sees the mass storage. It says 480 megs. Well, I've got a different drive plugged in, so that's fine. But anyway, we're seeing it. So now we can go on to getting the RAID software installed. Getting the RAID software installed just requires the one command, and I put the -y after it because that way you don't have to enter everything. So we should be ready to go here in just a moment. Just to be on the safe side, just to make sure that mdadm is installed. Okay, this says that we've got version 4.1, which is the latest currently available. So that's a good sign. Just always trying to have some checks and balances as we move forward. Gone ahead and attached both of the drives. I'm using just the USB 2.0 ports. This is not what I would do in a normal situation. I've got a 7-port USB 3.0 hub that I'm going to plug in, but I wanted to make sure that both of the USB ports were working before getting started. And we're going to see what we've got in terms of mountable drives. So we've got SDA, it's got a reserve section in here. Okay, so there's partition, NTFS, which we don't care. We're going to blow that away. We've got, it sees both the drives and it sees most of what we would have to do. It sees the partitions rather, so that's good. And then this right here is the actual boot flash that we're running off of. So everything appears to be good at this point. Now what we're going to do is repartition the drive because that should fix it, or at least it did for me. So we'll do sudo fdisk SDA. We're going to start the first one. So we'll say new primary partition and we'll say 1, and we'll just accept the defaults there because it's picking up the size of the drive. Okay, it's created, okay, partition type of Linux. All right. Okay, so we need to change the partition type. We're going to set it to Linux auto detect. Okay, so it's Linux auto detect. Everything's fine. So now we'll say write. Okay, so it's done that. Sudo fdisk. If I can spell fdisk, I seem to have a problem with that today. /dev/sdc. All right, so we'll go new primary and partition 1. We'll accept the defaults there and we'll print it again. Okay, that looks good. Now we will need to change the partition type. Let's verify that. Okay, and then we can click write. Okay, so it's done that. We are now through with the fdisk, and now we can go on to getting the RAID 0 set up. Well, now that we've got the drive set up, we're going to go first set up RAID 0. Keeping in mind, this is just getting the array set up. We're not doing any formatting or anything, but this is just to get it up to the point because this is where I had to get it in order for me to use Open Media Vault with USB-based hard drives. That's the approach I'm taking, and that's where we're going to stop because depending on what you want to do, there are further steps you can take. And I'll have links to other reading you can do in the show notes to kind of get you started. Now, just to make sure you've got your drive loader straight, you lsblk, and this is going to show you the drives that you're going to be able to reference. Now you'll see in SDC1, I'm actually going to go up at the disk level. I'm going to set up the spanning or striping or mirroring, whatever we happen to be doing. I'm always going to be doing it at the disk level. So all I have to do is change here, and it's going to say resource busy. That's interesting. Oh, because we've changed something. This is another little gotcha. If you see this message, then what we've got to do is do a reboot, because at this point, it doesn't understand what's going on. We will be restarting here momentarily. Stop the array. Now let's go through and start doing it. Okay, this is what we should see. It's going to talk about the different devices. It's RAID 0. Okay, it's going to say we're going to be blowing away what's there. Fine. All right, so it's now going to do that. So let's do cat /proc space /mdstat. Okay, it says RAID 0, use sudo mdadm. See, now this gives you the better picture of where the array stands. Well, it's not an array. We're running RAID level 0. It's working devices. It's already set, ready to go. It's in place. You're done. You can start formatting the drive. Well, now we're going to jump ahead to setting up RAID 1, which will be mirror drive. So you're going to see, instead of this large number here, you're going to see about half that because we're mirroring from one drive to the other. And I've taken this back to where we have just freshly partitioned the drives, and then we'll start from there. So we've got the command there. We're telling it to create MD0, and it's already started the rebuild process. So what we'll do is go up here, and now it's showing you resync, and see, notice your array size is different. So it's half of what initially reported before, still showing 2 drives, and then it's just a case of letting this rebuild, and we can repeat the command. It's just going to take it a little while. The drives are doing their happy dance right now, so the resync status is going to take a little bit of time before it starts updating. And of course, in this day of instant gratification, and we all want this now. When you're trying to get a handle on where it stands in the array building process, and it seems like it's sticking at 0 for quite a while, you can actually go back to your cat/proc/mds stat. It will give you an incremental version. So now we can actually see that the rebuilding process, or the resilvering, remirroring, whatever you want to call it, is actually up and running. Now you've seen what it takes to set up RAID 0 and RAID 1, keeping in mind, like I said in the other video in this series, that normally you would not use RAID 0 because it's an unprotected system. As far as if you lose one drive, then typically you're going to lose the whole data set. That's a reason, as a general rule, not to use it. Now, keeping in mind, when you hear RAID 10, you're taking a combination of RAID 1 and RAID 0. So you have, instead of a single drive, you would have, like, say 2 drives for one RAID 0 setup. Then you set up a second set of drives for another RAID 0 setup, and then you would mirror the 2, right? You can call it RAID 1 plus 0, RAID 10. That's essentially where it gets to. Now, what I'm not showing you at this point is the formatting of the drives once the array is done, because my whole approach at this point is to get the USB drives set up so where OpenMediaVault can see them. As you can see, mdadm is a very versatile tool. This is why you want to have a RAID lab set up so you can play with all this without spending a whole lot of money. There is a USB card I'll be showing in a later video that has additional USB ports on it, so you won't be bound by just the 2 that are on the Raspberry Pi IO card, but it will get you started. So this gives you a comparison now of setting up RAID. I'm waiting for a drive to arrive, and we'll actually go through and set up RAID 5. That's a little bit different beast, and then we'll take what we've done and actually go through an OpenMediaVault setup, because they've got a newer version out since the last time I looked at it. So this is going to be another reason that you'll want to take a look at some of this. Again, this is all something that it's a learning platform for you, so you don't have to worry about buying a bunch of what can be expensive drives to be able to get this up and running. But this will get you to where you start learning a little bit more about RAID, and then we can start looking at other systems such as unRAID. But this gives you the basic platform of what to look at. If you're watching this on YouTube, you will see videos on the screen that are similar to the one you've just watched, or other content that YouTube thinks you might be interested in. If this video helps you or provides value, please click on that like button, thumbs up. If you haven't already subscribed to the channel, please click on subscribe now and enable notifications. See you in the next episode. Thanks for watching.